This is R.D. Sharma solution, class 12, chapter 9. Continuity MCQ multiple choice questions we are taking. If fx is this, so the point given is pi by 2 and it is being told that this function is continuous at x equals pi by 2, that is 90 degree. So if you assume the first function to be a, on the left pi by 2 will take a, take the second function as b, we have to take the on the right hand side the b function. And this is continuous at x equals pi by 2. So which one of this is the correct option? So we just have to find out the left hand limit and the right hand limit, and we need to equate, and the relationship will be in front of you. Okay. So point of contention checking continuity is pi by 2. So left hand limit and right hand limit we are going to take. In the left hand limit will take x as pi by 2 minus h. Right hand limit we are going to take x as pi by 2 plus h. So this is pi by 2 minus h. So this is m into pi by 2 minus h plus 1. This is what we have taken the first one. But on the right hand side we'll have to take the function b, which is sine. I'm replacing this by pi by 2 plus h, sine pi by 2 plus h, and plus n. Okay. Now, this sine 90 plus theta, you have to understand that it will be cos theta and positive cos theta, cos h it will be. First we'll solve this, m into pi by 2 minus mh plus 1. Just apply the limit and make the h term, whichever term is there, it is 0. So see, assume this h is very small. So we can just eliminate it. M pi by 2 plus 1. This will come on the left hand limit. Right hand limit, it is sine 90 plus theta. If you just go through this add sugar to coffee, that is where the different trigonometric terms, they are positive and negative. That is how we see here. So sine is positive here, sine 90 plus theta is cos theta, cos h it will be. So final is cos h plus n. So this is n. So cos h plus n, now apply the limit here also. And when h is 0, what do you get? Cos 0 is 1. So h tends to 0. Cos 0 is 1. This is 1 plus n. So left hand limit and right hand limit we are going to equate. X is pi by 2, so let us equate it. M pi by 2 plus 1 is equal to 1 plus n. 1 gets cancelled, m pi by 2 is equal to n. And what do you get? You get m pi by 2 equals n, and this is the correct option. The value of f0 so that the function this one becomes continuous for all x, this is given by. Now f0 we have to find out. How f0 we are getting? Because we have to take the limit of fx at x tends to a is 0 here. So f0 basically we have to find out. So it is limit only. So this question will contain a lot of rationalization, and writing this again and again will be will take some time. So let me just brief you again. Limit x tends to 0 or x tends to a is 0 in this case, fx is equal to f0. This f0 we are going to find out. So as I was suggesting, that this question has a lot of the terms which involves rationalization. So to rationalize, let us write them in a smaller version, and then we'll take them in deeper sense. What I'm trying to suggest here is, I'm taking it as T1 and T2. Just to let you know, the below one or the denominator I'm taking P1 and P2. Just we don't want to write that much. So here, just in order to understand, please assume that we have to first rationalize the numerator, or you can start with the denominator. I am rationalizing the numerator. So you have to just multiply by the plus sign. Same term with plus sign. What you will get? A minus b and a plus b is a squared minus b squared. So root 2 t1 square minus root t2 square. So you will get t1 minus t2. So here you are going to get a square minus ax plus x square and minus this bracket minus a square plus ax plus x square. Now just subtract a square minus ax plus x square minus a minus ax minus x square. So you just cancel these terms. This also you get minus 2x. So the numerator has been rationalized and you get the result as minus 2x. So what is remaining here is under root p1 minus under root p2. I have assumed p1 as a plus x and p2 as a minus x. So root t1 plus root t2 will remain. And I am going to rationalize this denominator. So let us rationalize it first. So same thing. When it is a negative sign, you just multiply it with the positive sign. So root p1 plus p2, and here also root p1 plus p2, just multiply this. And in the denominator, you have root p1 minus root p2. Okay. So a minus b, a plus b, same thing we are going to do here. So you will get under root square, that is, you will get the p1 and p2 term, which we assume to be a plus x and a minus x. So p1 minus p2 is a plus x minus a minus x. So let us write it here, a plus x minus a minus x. So this will be a plus x minus a plus x. Get this cancelled. X plus x is 2x. So you get minus 2ax divided by 2x. And this you have got from the rationalization. But the plus sign still remain. Root p1 plus root p2. And in the denominator, root t1 plus root t2. Okay, this is t1, t2, just to make you sure that this is p1 plus p2, p1 and p2. Okay. Let us now cancel these two, minus 2x and minus 2x you can cancel. And only, no, there is just negative. So only minus a will remain. The result will be only negative a. You can just cancel these two out. Here you can apply the limit now. So f0, that is, in the place of x, just put 0. In place of x, put 0. So a plus 0 is under root a. Let us do with the this denominator I am doing. Root a minus plus root a, because it is under root t1, p1 plus p2. Please remember. Numerator I am taking, numerator is under root p1 plus p2. Now coming to the t1, t2. T1, t2 is the numerator. Denominator is becoming numerator, numerator is becoming denominator with a plus sign. So what do you get? Under root a square. Here also you get under root a square. Excuse me. So we have a plus a, and the numerator, what do you get? Minus a. This is twice of root a, and denominator you have 2a. Now you can just cancel 2a, 2a, and only minus root a will remain. What will remain? Minus root a. So this is your f0. So the main key idea of this question is to rationalize and find out the limit. Most of the question, the result is minus under root this value which is coming by the limit. So what is minus root a? So minus root a is not there. So see, root x is simply x raised to the power, or a under root a is a to the power half. So it is negative. So this will not be the answer. The third one will be the answer. C is the answer. Now question number 17 it is. Now since modulus is not in the value of the function, but in the boundaries of the function, or the domain, or you can say on the limitation of the various boundaries or aspects. So I'll just take this question later in the end, because this needs some effort. So I'll tell you about this question later. Let us finish all these first. Now this question and the next question, few questions are exactly like this. So you have to apply the same technique or logic in the other questions as well, right? So let us see it. This is f0 we have to find out. So what we have been doing, same thing we have to do. we just have to find out the limit of this function. And limit of this function, essentially it is f0 only, because limit x tends to 0, x tends to a, it is a is 0, fx is equal to f0. So you have to find out the limit essentially. And you need to have a fair idea about the roots, cube roots, nth root, how are you going to write it. And one more factor, one more important aspect of solving this type of question is this particular question is a raise n minus b raise n divided by a minus b. When you take the limit of this, what are you going to get, right? When you have this a form of this, and when the limit is, when limit x tends to infinity, it becomes different. We are talking about x tends to 0 here. So 27, you're taking the numerator first, 27 minus 2x raised to the power 1 by 3, and both n should be same, so we need something of power 1 by 3. So what is 27 cube root? Cube root of 27 is 3. So in place of 3, we can replace it by 27 raised to the power 1 by 3. Raised to the power 1 by 3 is simply cube root. Now coming to the denominator. Denominator, same thing we are going to do. Okay. So a minus b we have to do. Now since numerator we are taking, we have to introduce a minus b also. 27 minus 2x, just write this a minus b, that is 27 minus 2x and minus 27. So this we have introduced by ourselves. So what, this is a, this is b, so if the above is a and b, we have introduced by ourselves. So what is remaining here? If you cancel this 27 out, which we have by ourselves introduced, so minus 2x is extra. So since you have introduced the denominator, you have to put this minus 2x in the numerator also in order to cancel it, or make it the way it was earlier. Minus 2x we have introduced, right? Now this relationship, what is this final we are going to take? I'll just show you. This minus 2x is the extra. I'll just tell you what to do with this term what we have made. The solution of the numerator, when you apply the limit x tends to 0 in this, is going to be this 27 and raised to the power 1 by 3 minus 1. See, 1 by 3, the power will come in front, and then you take 27, which is b, raised to the power 1 by 3 minus 1. So 1 by 3 comes in the front, 27 you take here, raised to the power minus 2 by 3. How did this has come? 1 by 3 minus 1. So the power n minus 1, n comes front. So n, 27 to the power n minus 1. I hope you got the idea. Minus 2x was already there. So the numerator final we have done. Now coming to the denominator now. Denominator, same thing we are going to do. 9 minus 3 and 243 plus 5x raised to the power 1 by 5. Now this 3 is creating some kind of you can say bottleneck. So you can just take these 3 out. When you take 3 out, you have to take 3 common, so that we can get a proper form which we want, as we just did in the previous numerator. So we are dealing with the denominator, and since we have 1 by 5 as the power, and we need this something of the sort a raise n minus b raise n. So I am taking 3 common here. We have 3 inside, 3 has already been taken. So only 243 plus 5x raised to the power 1 by 5. Now we have b raised power n. Now this also we have to make something. So what is the number whose fifth root is going to be 3? So simply you can say x raised 1 by 5 is 3. So you can raise the power by 5. 5 gets cancelled in the left side. So it is 3 to the power 5. And 3 to the power 5 is simply 243. Okay, it's 81 into 3 basically. So you have 2243 raised to the power 1 by 5. 3 is already there. Please remember. I'll just mark it so that you know what we are going to use later, because these terms we just forget and we don't get to the proper answer. We have this 243 and this 243 raised to the power 1 by 5 it is. 245 raised to the power 1 by 5 minus 243 plus 5x raised to the power 1 by 5. So we are getting to this a raised n minus b raised n. But 243, see, we have to just change the position because a raised n is not following the proper way we have to do. So I am taking the 243 plus 5x term first and then 243 term later. And since we have done this, we have to take the negative outside. So we have minus 3 outside. And we have to have in the denominator 243 plus 5x minus 243. But when you solve it, you will get a 5x extra. This 5x extra has to be put in the numerator of the denominator because we are dealing only with the denominator. So 1 by 5, what is the solution? 1 by 3. Now 243 to the power 1 by 5 minus 1. 1 by 5 minus 1 is what? Minus 4 by 5. Here minus 4 by 5. This is the denominator and you have a 5x also. You have a 5x which we have introduced. So let me tell you what all we have done. There are certain things which are there. So the numerator is 1 by 3, 27 to the power minus 2 by 3 into minus 2x. Denominator is 1 by 5, 243 to the power minus 4 by 5 into 5x. So I'm just writing them and I'll just clean all this and try to make them more clearer to you. But I hope you got the idea what we got in the numerator, what we got in the denominator. I'm just writing it for the sake of understanding that this is numerator, this is denominator, right? So let me do it again. Let me just write this, what all we have got. Minus 2x was there in the numerator, minus 5x was there, 5x was there in the denominator. Minus 1 by 3 was there. Remember, minus 1 by 3 was there, and we have the 2 by 15. You will get 2 in this minus plus 2 by 5 is a 15. So 2 by 15 you got. What about the numerator denominator value? 1 by 3 was there already, and this is 27 to the power minus 2 by 3, and in the denominator you have 1 by 5 and 243 to the power minus 4 by 5. And this minus 4 by 5. So this is 1 by 5, 1 by 3, 1 by 5, 5 goes up, 3 goes down. And this 243 to the power minus 4 by 5 and 27 to the power minus 2 by 3 can be taken up and down because 1 by x raised to the power minus 1 is numerator x to the power 1. So I'm removing the negative sign. Now you got 4 by 5. What is 243? 3 to the power 5. 5 gets cancelled, you get 3 to the power 4. And this 27 to the power 2 by 3, 27 is 3 cube, sorry. So 3 cube, this 3 gets cancelled and 3 cube it is. So this 3 cube gets cancelled, you have a 3 square only remaining. So you have 3 raised power 4 divided by 3 raised power 2. So that is 3 into 3 into 3 into 3, and denominator you have 3 into 3. So 2, 3 cancels, you will get a 9 in the numerator for this. Rest constant is already there. 2 by 15, 5 by 3, all is there. But you get here 3 by 4, 3 raised 4, and you have 3 raised 2. So this gets cancelled, 3 square it is. Now you just take all of them. 2 into 5 into 3 divided by 15 into 3. So just cancel these out. Everything gets cancelled. Only 2 will remain. So the final answer is 2 here. The answer is 2. Okay. Okay, this is the same question almost. So we'll be taking it in the next discussion. Till then, thank you so much. Take care of yourself.